Naturally, I'm overwhelmed with gratitude and warmth at the sense of pleasure that everyone's expressed in the years that I have worked or done something with many of the people who are here and many of you. I'm especially grateful for the last 20 seconds, which I recognize is also not only very warm, but also free from hyperbole, which was not true of all the other. I wish I had done some of those fine things that people said I did. But anyway, I might have tried, but I don't know. They put a very golden glow on past hints and ventures and efforts, which, as everyone knows, are never quite what the reflective theorist says about them later on. I want to make one very early comment, quick comment, and that is that physicists are very poor at dates. For example, I myself can't get over the feeling that the 20th century began in physics. The 20th century in physics began on the 1st of January, 1896. Well, it's only 4 years off to be sure, but that is something. But that is a date, of course, which Röntgen's famous paper discussing the X-rays was printed, circulated through the world, and began the tremendous impetus which we still feel from the turn of the century events, the radioactivity, electron, and Röntgen rays. So the physicists missed that by 4 years, which is not bad for a whole century. And I must say the organizers, in celebrating their 70th birthday on this date, are again taking a certain liberty, but depending how you calculate, they're only 10% off or only 1.5% off, and either of those results is probably good enough in our trade. But something else for the benefit of people who were present last night and who took part in our splendid dinner, which will exclude, I think, many of the people who come this morning to hear these delightful talks, which, as Professor Lowe said to me, and we won't steal his idea, represent kind of two poles of excellence in our public communication as physicists, a technical, brilliant, clear, and powerful talk, and a wide-ranging commentary of the greatest importance to every auditor, from Carl on the one hand, from Hans on the other. A remarkable demonstration of what the community does include. But people who were there last night will have taken part and also witnessed a very generous gift which people gave me, a superb high-frequency receiver and transmitter box of enormous technical, the latest thing, the state-of-the-art, quite a marvel. And I wanted to justify that a little bit by saying that I really am a kind of saturated with that strange attitude towards radio, which is characteristic of, I'll say more about it in a moment, of many other technologies in our present world. They attract people who have no particular professional concern with them because of the remarkable experiences they offer and challenges. For me, it goes back very far, and perhaps this anecdotal material is worthwhile. It's, I think, what's appropriate on such an occasion. My father, who was a most active, alert, and intelligent man with very little, no technical training or interests, and not very much formal education, knew his way around the world extremely well and could calculate wonderfully, mostly the flow of the cards, bought me, for my 5th birthday, a remarkable device then on sale had been on sale for 2 weeks, just 2 weeks, in one of the big department stores in downtown Pittsburgh where I was growing up, Joseph Horn and Company, who sold in those 2 weeks something like 3,000 crystal sets, which were called Areola Junior. They were made by the Westinghouse Electric Manufacturing Company, and they were intended to attract an audience to the first broadcast station anywhere in that part of the world. Of course, a lot of disputes who was first, but KDKA Pittsburgh was widely held to be the first commercial broadcasting station in the United States. Perhaps it's not even true, but it's a worthwhile tradition. They broadcast from the Westinghouse plant, and we lived about 3 or 4 miles from that place, in a place called Wilkinsburg, PA, and they were in East Pittsburgh. My father knew I'd be interested in such a thing, and sure enough, for my 5th birthday, I got this remarkable affair with this little crank-like dial. Its 2 coils, which mutual inductance was variable to tune it. and its early solid-state device called a crystal of galena, and a hard wire which you touched against it, which made it possible to hear the election returns of the Harding election, which is not something very exciting to me, but quite a lot of other things as well. And I became glued to that and quite a radio enthusiast from the age of 5. And maybe that's responsible for whatever else happened to me. I don't know. We know that bending twigs inclines trees. It was certainly a severe bend to my particular twig. I remember about 2 years later, I organized the neighborhood kids to build in the wastelands of high grasses and discarded tires behind our house. We built a hidden, secluded nest in the woods, which many kids do at that age, and we fitted it up with powerful radio receiver and transmitter, according to my own design, the chief ingredient of which was a broken clinical thermometer, which had a wonderful calibration, and you felt it was really a fine device. It was quite nice, too. I can't say that it worked, but it looked quite impressive. And I did become, of course, a devoted radio amateur from about the age of 9, and was a radio amateur for many, many years until I became a graduate student, and I had to work too hard and gave it up. And I hope to go back to that if I ever can get out of making television programs and working too hard doing that, but we'll see. In any case, we turned the set on last night. It has marvelous 40 or 50 push buttons and levers and so on. Even to read the manual would take 2 hours. So we just played around. I did coax a few signals out of it, and when I left this morning, I had already heard, quite a lot of the usual powerful broadcast stations, knowing how that works. It works fine. It's a wonderful device. It has full of severe phase-locked loops, which give it a powerful way to pick out frequencies. And I tried it on WWV, the father of time in Fort Collins, Colorado, the official station. I noticed with considerable admiration for the designers that the frequency recorded in this 10 megacycle carrier was 10.10.000.0 when I deadbeat the... So they have their act together between Fort Collins and the firm. So I do thank you all who took part in that, and those who just willing to listen to it. It was an exciting, wonderful gift for somebody who has quite a lot of things and doesn't need much more, but this was splendid. Now, I want to talk for a little while, and I think my task, I'm going to make a rather brief talk, but I want to talk for a little while about community, because that surely is what we're celebrating and discussing here. A community of shared tasks, of mutual interests, of widespread, commonly felt concerns, of experiences, positive and negative, attractive and repulsive, which we've all come to in the many bilateral and many-body exchanges which occur in a professional group like ours. I'm speaking the physics community, and especially that sub-branch of it, mostly people here, who have drifted a little bit from the purest physics into astronomy, including, of course, from the beginning, Hans Bethe, who couldn't stay away from the stars once nuclear physics could be powerful there, and is still dealing with the same old star after all these years. I had a hard time thinking how to order this thing, and I thought there was a wonderful cosmic order which I would use. It is the fact that we share world lines, and though we know our times are distinct, because our motions are not zero, they are pretty small. And therefore, I think we will say there is a public time which we on Earth, and even people in orbit or in the solar system, share to high accuracy, good enough for all everyday purposes, and we can deal with that. So I'll try to order things a little bit in that order so to make you feel something of the experiences that I want to tell about. I'm going to try to stay away for the most part from giving you wonderful things to say about some of the people who are here, but if you send a self-addressed and stamped envelope, maybe I could fill those in. It is true that a community is built not only by the things that I've talked about, or the real things that are behind it, the day by day and year by year reading and talking and arguing and exchanging letters and fighting and agreeing and so on, and contesting for this and that and agreeing for this and that. But also by tradition and record. That is to say, by things that are expressed and made public. And this is a necessary part of it. Publication, the most formal, and bar conversations, the least formal, both of great importance, as everyone knows. So I want to say a few of those things, mostly by people you won't know of, but they reflect, if you don't know about them, you'll at least see me saying them, and that provides a kind of relevance to the situation. And I first want to say that I never can face such an account as we've had this the last day or two, as I had even 10 years ago, a similar, related sort of thing, without thinking of the first time I listened to a talk by the distinguished and wonderful American physicist astronomer Henry Norris Russell, from a different generation, but also a man who had a great deal to do with the magazine for which I worked so happily for many years, and a man whose name is carved firmly into the physics of atomic spectroscopy, let alone the stars and their nature, which was his real study. First time I saw Henry Norris Russell, I was a rather callow sophomore. He was present at a meeting of the Astronomical Society in Pittsburgh, which at a Christmas time, when the AAAS, the American Association of Advancement of Science, met there, and many scientific organizations met in their ambience, in their halo, more than do now from the physical sciences, though the biological sciences are strongly still represented there. And I remember thinking to myself that, which I had already gathered this view from literature, so it was perhaps not an original idea, I imputed something to the world, that astronomers must be people of great longevity. Here was this vigorous man saying very nice things, a little bit of which I could understand, not much, but clearly a man in full possession of all his powers, and he was formidably old. I thought of geological age. He was, according to my researchers, about 61. So again, the relativity of perception is made very clear. In order to add to steal a certain distinction from the past, I should now I was reminded of my two encounters with the most famous name in 20th century physics, the name of the wonderful Albert Einstein, that man. I mention it because it's the very same occasion in the Christmas season 33, 34, yes, when I was a sophomore, that Einstein came to Pittsburgh exactly as Russell did, for the same general purpose, to attend the AAAS meeting. That was a time when Einstein had not yet realized fully that dreadful social malady which affected him in America. Namely, if he walked down the street to buy a newspaper, he would acquire an accompaniment of 300 people, if you were not careful, except in Mercer Street and Princeton and a little bit in the neighborhood. And this made his life, as he said repeatedly, difficult, because he couldn't do the normal thing. He couldn't go to the theater, he couldn't go to the beach without making a kind of a strange situation. So he hadn't learned that yet, but he learned it in Pittsburgh. He announced the talk to the section of the Physical Society, which was meeting there. Quite a straightforward, pleasant, elementary pedagogical talk, deriving the Lorentz transformations from momentum conservation by a new method, which he had just thought of. I don't remember the details, but it's published and was quite useful for people who taught about relativity. And he gave this little talk to a meeting expected of 150 people or so, the registrants of the society. Well, of course, you know what happened. The place couldn't hold it, and so there was huge demands for getting in, and so the AAAS hired the largest theater available at that hour, and then began to give out tickets because they couldn't control the crowds. And of course, all of us physics students who lived and worked at the Carnegie Tech campus, which was 1,500 feet from the Carnegie Theater where this was held, couldn't stand the fact that we had no chance of getting in anymore, because we had no right to those tickets. They were given out, to all sorts of dignitaries. And so the whole place was going to be filled with 2,000 people, 25 of whom were interested in the topic, and the rest were interested in saying they had seen Professor Einstein, which is not an unworthy thing. I'm not trying to run it down, but obviously it had its price on Professor Einstein himself, and a little bit of its price in the currency of science. But the students, undergraduates, as this university knows very well, are not easily constrained by the architects and the formal rules and the police and all those things when they want to do something. And so the place was a theater, and the Carnegie Tech has a drama school, And drama school is full of people who know a lot about theaters, and quite a few who had rehearsed in this very theater. So it didn't take much looking around to find somebody who said, okay, we'll get you in, don't worry, we'll all go there together. And of course I ended up, well, this place is too small, but in a place way up there, and by looking, my angle of view was very small, and it contained the rear of the stage. And so I could get a very good view of the edge of the blackboard, but not the blackboard, and an occasional view of the top of Albert Einstein in his hand. And we couldn't hear a word. And we were in some peril of falling out of the fly onto the stage, which we avoided. But anyhow, that was my first encounter with this great man and great physicist, and it's only rather amusing to talk about it. But I did want to add another story, another authentic, genuine eyewitness account of Einstein's sense of humor and repartee and understanding, which I'll make very brief because it's not my job to do that. There are only a few people now who are witnesses of Einstein, but one of the best is here, Professor Peter Bergman, and I said I would just allude to that, so if you want to know the real goods, ask him. But if you just want to hear a story, I'm good enough for that. And I was introduced by a mutual friend who lived on Mercer Street to Professor Einstein very late in Einstein's life, only a couple of years before his death. And it was a very pleasant Sunday afternoon. I went over, just as any guest would go, to a Princeton household on a Sunday afternoon. We chatted and had tea and all that. And we talked about the political situation in 1953 or so was not very good, and we had mutual understanding on that. But I don't want to say all that about the conversation, but I want to mention one remark. Einstein asked me what I was doing. I was then a young professor doing cosmic ray sort of things. And he said, I realize, said Einstein, that there are two great enigmas in the world, which I myself have not given any time to study, but I think they're very important, and they will contain in them something of great value. One of them, he said, is the origin of the Earth's magnetic field. And the second, he said, is the origin of the cosmic rays. We don't understand these two things, and I'm sure that there's a deep piece of physics in the solution to these two problems. Well, this was a gift, I must say, because I knew something about those problems. I didn't know the answers, and I'm not sure I know yet, but I knew something about those problems. So I said, as diplomatically as I could manage, well, Professor Einstein, I don't think it's fair to say that these are really big enigmas going deep into the heart of fundamental physics. They might have been at one time, but it's not true any longer. We do have a general idea of how both of them work. We don't know where or when or in detail, but they seem both to be related to what I will call, for short, I said it a little better then, hydromagnetics. That is the idea of magnetic fields in fluid conductors, which are capable of translating bulk mechanical energy to charged particles by this interaction between a current, which is locked to a big mass of fluid, and a single particle which can respond to the moving magnetic field. And this is probably in some way related to the Earth's magnetic field, and in some way related to the acceleration of cosmic rays. And he asked a question or two, and I satisfied him. He had never heard of Alfvén or magnetohydrodynamics or any of those matters, as far as I could tell, unless he was just being very polite. And finally, he smiled a little bit and said, well, he said, I see. In any case, Morrison, you can rest assured that in your work, Einstein is no competition. This was pretty good assurance. I can't fail to go ahead a little bit. As I said, I was doing it the T sequence. I jumped that. I made a slight mistake. But let me go back a little bit, because I was thinking so much of my student days that I put the two Einstein stories together. As a student, of course, I was fairly ingenuous graduate student when I arrived. I had come from Carnegie Tech, a good school, with excellent interaction with the physicists, who, by the way, had, by their simple being there, had seduced me away from the radio engineering that I was planning to take up when I became a freshman. I only had to go to 6 lectures in electrical engineering and 6 lectures in physics to see that my heart belonged with the physicists. The subject matters might have been much the same, but the attitude, the community into which I see myself working was so different. Exploratory, seeking grasp, not satisfied with mere compact results, unexamined, to go to the next step, and so on. And it was so much more my style that I became, for better or worse, a physicist. I never did become a radio engineer, though I worked at it a little bit in my college days. When I went to Berkeley in 1936, I began to become interested in nuclear physics. And of course, what I had was the wonderfully clear and powerful article, always known as Bethe and Bacher, but especially Part A. The theory was Professor Bethe's work of the time, and it was a good, thick, compendious object, which I didn't understand very well, but which I studied and studied and studied and kept around, and finally got to know quite a bit from inside it. And I am dazzled and delighted to be able to come back 50 years and still have such a sample of understanding about these things so nicely given us by Professor Bethe himself this morning. And it's a great pleasure. Of course, Hans is a kind of second teacher of mine, and we worked together for years. And we wrote a book together, or he wrote at the beginning, and I modified it very happily. And I have to regard him as a lighthouse. Not always clear, sometimes a little foggy out there, but definitely the direction you want to go. And that was and there he still is. I have to say that I was especially poor at neutron physics. I never figured out that part of the chapter very well. Until I was taken to the University of Illinois a little bit later. I had my degree then, it was sort of a electrodynamics, a QED degree, with 3 or 4 papers in applications of QED to various nuclear atomic problems. Very, very instructive and very pleasant, and liked it a lot. Learned a great deal, and worked with my partners, Dankoff and Schiff and Cooper and a few others. And we were a very cheerful part of that remarkable assemblage of my fellow students who were the students of Robert Oppenheimer in the last of the 30s. Well, when I went to the University of Illinois, I found myself in an office, and the other man in that office, I was a very junior instructor, and he was getting ready to go away, was none other than M. Goldhaber. And I knew he must know something about neutrons, since essentially he discovered them, and had kept up with it quite a lot. And indeed, he was indeed busily working on neutron diffusion problems for reasons I didn't quite understand, which I understood pretty soon when he went away to Chicago, where I felt there were lots of people collected that. But I was very, very little understanding about those matters. But I was understanding enough so that and this is a repeated story all over the world, it's probably worth saying it has enduring historical meaning. In the early spring of '39, in LeConte Hall, room 219, with a few other graduate students, we spent a long afternoon. That was Robert Oppenheimer's ante-office, the adjoining office. We always talked and argued about things there. And that afternoon, we were led to think about grave matters, and we constructed on the blackboard an extremely naive, but not wholly absurd, model of a nuclear bomb. And this was, of course, February or March, I can't say which, of 1939, safely after the Frisch-Meitner articles, so they understood about fission, and in the hands of people who didn't know much about neutrons, but knew some catchwords and some broad qualitative ideas about what neutrons would do and how a reaction might propagate. And we weren't clever enough to think of delayed neutrons or that, but we understood what fast neutrons would do, and it was good enough. So that was a kind of sign of the trouble, which then caught me up in the war, and I won't say very much more about that. It's a long discussed problem. I do want to mention, though, when I look at this excellent group of people here yesterday, into a large group, sampling my whole world, there are very few people around who still go back to the Berkeley days that I recall. There are 2 or 3 I want to mention who are absent, Dale Corson, who could not be here, and Robert Wilson, who is lecturing in Yugoslavia today. And they're about the last of my fellow graduate students whose location I can name. Most of them are not here. The other one is Bernard and Hannah Peters, whom I knew in Berkeley in 1938. And I think that somewhat takes the record for longevity of association among people I've met. Alvin Weinberg claims that he saw me at a Beethoven quartet in the late summer of 1936 in Berkeley, but we couldn't quite verify it. He claims I was fixing the audio equipment, but I don't remember that, though it was certainly possible, and it may be that he's right. That would antedate a little bit, because I didn't do that long at Berkeley. I just barely got a room when I was still doing that job. I also would like to describe, as part of this sort of anecdotal melange that I'm just beginning here, I want to say a little bit more self-justifying stuff in a moment, in a more generalized way, but it's nice to have a few such items. I very clearly remember, though I cannot tell you the exact date or the exact place, but I remember it was a Physical Society meeting in the mid-60s, and it will have taken place someplace where the spring sun was shining on the grassy lawns, and I suppose it was the Washington meeting of the Physical Society. And there I was approached by Ray Davis, whom I knew very, very slightly. But Ray had read something I'd written about doing neutrino astronomy and things of this sort. And he told me his plan for burying the cleaning fluid in a big tank in the bottom of the Homestake mine and cleverly extracting from 20 tons of the stuff, 20 atoms per month, or whatever it was he was talking about, to check the neutrino. And did he think it was worthwhile? Most people said he, that it was all calculated, there was no need doing anything about it. And I said, don't believe that for a moment. You don't know anything about it. It's a way to look inside the sun and do it. And on his behalf, with many people, I did what little politicking one could in favor of the experiment, which I must say was brilliantly supported in the end by the Brookhaven Laboratory and by the authorities beyond that, and got us this long, rigorous series of month after month disappointing answers that never fitted all those clever theorists' work. And he stuck to it, as Hans said, and out of that sense of integrity will perhaps already has come, a remarkable study of the interior of the sun that seems to verify, probably will, our picture of the stars, but also, as Hans has opened up to us, a considerable more that we can look at, which we never imagined. It does no use having a result that is popular for the moment, but does not endure. It's much better to have a result, however unpopular, however frustrating, endures because it is, I think, right. And that's what that's what we ask for, to always get it. So it's 20 years since that happened, and it's a wonderful, wonderful conclusion. It's very hard to work time after time in a deep mind and always come back with that same result, and you try this or that statistic, and no matter what you do, you still get a disappointing answer. Another remark which was made by Alan Guth yesterday, which I wanted to pick up a little bit, just to mention people that we all know. And this is something that has been published. I don't know this of my own, but I just read it and I verified it with the author, so it's true. It's the story of the enormous intuitive perception of that thoughtful, reflective man, Niels Bohr, who, having thought about all hard problems, was then able to see, when you brought him some new thing, which of the hard problems he thought about it was connected with, which it was solved. And Henrik Casimir writes, said in the Bohr volume, of that remarkable calculation of Casimir's on the forces between the so-called van der Waals forces in the limit when you throw away all the molecular structure. You get an answer which does not depend on any of those points. It doesn't depend on the charge of the electron or anything else if you go to the right limit in looking at surface-surface interactions. He made that calculation. It rather puzzled him that there should come out such a result, but it was clear. He mentioned it to Bohr, and Bohr looked at him quizzically in that way that he had when there was something quite important, a half-veiled look. He said, then, Casimir, that is due to the fluctuations of the vacuum. And that is what we believe, and I think the fluctuations of the vacuum, on which one of the three pieces of my thesis was on pair fluctuations in the vacuum, I think they have acquired now. They've been sort of buried under the rug for a long time. Then they were shown to be real in the great days precedent to and just following the Lamb shift, where the polarization terms were visible, and the Casimir effect and the verification experimentally. And now, of course, the interpretation is still ambiguous, but now giving them gravitational meaning has led to a whole quandary which we don't understand, but which looks to be about as important as any cosmological theoretical subject that we know. And it's an interesting study. Now, enough of these points, but I think I am entitled to some account, or you're entitled perhaps to some account of why these wayward apparently extraneous items which have dotted this program, I think, very pleasantly, and I hope for you as well, but including the balloons or whatever you say. How come that a physicist should have this? And I believe it to be the most natural thing in the world, and that's what I'm going to try to say in self-justification. Why are these things here, and what relation do they have to the professional work of a physicist? I believe that in this order of importance, the least important first, but a very interesting case which we had demonstrated, magic, mime, and more broadly, playful science and engineering are topics of the greatest weight and importance in the modern world. And I think it is urgent upon many people, especially those who have academic influence. You don't need to worry about it at MIT. It's safe here. The extracurricular activities of students span such an enormous range of playful engineering and playful science that faculty doesn't have to tell them what to do, but just get out of the way and maybe give them a little money from time to time. It's not true everywhere. It is unfortunately the least true where it's the most needed. That is, in the broad public, in the schools, in people that are not so available, who do not have available all the resources of our campus. But magic, of course, is essentially the exploitation of a detailed physical knowledge of systems in such a clever way, a clever interpersonal way, that you're misdirected from trying to understand the answer. It was done for us yesterday by two adepts, theoretical physicist, astrophysicist called Ken Brecher, who punctured balloons. He tells me just like that, you just puncture it. And Max Maven, another old friend, a theoretical astrophysicist only by descent, who carried on very much more elaborate and polished affair in much the same direction. But this is very interesting because both of this procedure depends upon a detailed understanding, step-by-step understanding of a mixture of psychology and Newtonian mechanics and a little bit of physical chemistry and the like. And that's what it is. And it isn't much else. It also is a great understanding of human perception, of where you look at big moving things and don't look at small things that stand still, and a number of other such clues which are quite easy to face up to if you try to analyze what you mean by the instruments through which you survey the world. That is, your eyes, ears, and so on. And of course, nobody can, in general, without long training, can penetrate the rapid-fire, quick-changing goals and methods of the professional magician, or even the talented amateur. And it's very worth trying, but it will not generally succeed. But understanding that point, and understanding it, is very entertaining and is deeper because it suggests what is meant by the difference between a plausible perception and the kind of testing perception which is our aim in physical sciences, in natural science. And that's really the point that it makes. Mime, which is a specialized form of stage magic, of stage performance, I think is especially interesting and has always caught my fancy, especially in the hands of the great French masters, in the hands and feet of the great French masters, because they require a detailed understanding, much as the theoretical physicist seeks to have, of some mechanical operation in order to simulate its perceptual qualities without actually doing it. When Marcel Marceau walks across the flat stage telling you he's climbing 7 flights of stairs to the top of some Paris garret, you can see the motion of all the muscles, you can see him tiring, you can see the tensions change. It's compellingly convincing, it's there, persuasive. And he's only been able to do that by watching carefully over and over again what are the significant clues as that stance is adopted. In a way, it's a representation of the real physical world through a symbolic and analogous structure which is very much like what physicists do. And I think it's very close to that and deserves the wide appreciation it does have. Finally, a much larger topic, which I don't want to elaborate on, is what I call playful engineering in science. That means everything from toy balloons to kites and the great fence thrust 30 miles across California by the artist Christo. Why do I say these things? I think it should be quite clear. If we regard science technology, if the general world regards science technology as only the source, on the one hand, of a livelihood constantly subject to change, and on the other hand, of a fear of war also subject to uncertain and terrifying changes, I don't think our activities will prosper. I think they will become, as already they have in many ways become, regarded as arcane and fearful. And a great many people stay away from them at all costs. Perhaps the worst of that is a bit over, but it certainly we've gone through it. And I think that one reason for it is we always present it, it's always presented in the same emotional tone, either by its impact, sometimes good, sometimes bad, usually bad, or by its achievement on the part of people that you can't emulate or understand. Those are the two ways which it appears to us mostly. And it can't be left in that emotional domain of simple analysis or impact statements. It's fine, but it's not enough. It must be done, but it is insufficient. And I think it'd be much more rounded if the prose and the emotional tone and the context in which you encounter these things have the participants of enthusiastic amateurs and have the emotional tone of play as much certainly for the general public as for physicists, who certainly have that emotional tone a great deal, even when they're doing their most serious work. And the fact that we filter that away is very bad. So it was Gerald Zacharias and this institution that pushed me into a wider spectrum of education, away from education centering on the community of the physicists, which I was heavily engaged in, and gave many lectures and many little booklets and courses and so on, and into a feeling that education was a wider spectrum than that, which of course he was absolutely right, into beginning first in the high school, then largely influenced by Francis Friedman, into the elementary school, and here and there into the media, both through my magazine connection for so many years, and repeatedly in the BBC and in PBS to television in some form or another, now which I'm heavily engaged in at the present time, and will be certainly for the next half a year anyhow. I don't say much more about that, but I feel it's an absolutely natural boundary of physics. Physics does not take care of that boundary, make sure that there's free tourism across that boundary and that the customs officials are not too strict, and a lot is imported and a lot is exported. That's what we need for a healthy science. A lot of physicists in every department know a good deal about, say, solid-state manufacturing or anything of this sort, and that they don't know anything like that much about the schools and how they work was an early complaint of both of Zach's, and which I think I share. So I very much think that besides what I said, the playful side of the thing in a public and amateur way, the educational boundary is another important boundary. And then, of course, in a somewhat different, completely different vein, it's the most natural thing in the world to be concerned about armaments. It has to be said that indeed the most fearsome were made by us, often by the people I see here in many ways. It was not the government and General Groves who came to the Physical Society and said, appoint 12 experts to form a committee to see if we should make an atomic bomb. It was not that way at all. And maybe that'd be the way it be today, but it certainly wasn't that way then, and the illusion that it was that way, which affects many people, is a false statement. The situation, as you know, was almost the opposite. I'm not saying this to exculpate or involve anybody, but it's simply a true statement, and you have to evaluate it as you will. The physicists demanded the darn things for reasons which they seemed good and sufficient to them, which I still think probably were good and sufficient in the light of what we knew, and they finally got them. But it wasn't at the urging of the government. So I think that responsibility was borne on everyone, and I could say by the heat of that I felt in my face at the Trinity shot at 18,000 yards, I was pretty well committed to doing something about getting the thing put into a proper situation in our very large international society. I can't talk about these matters in great detail, but I just allude to them in this simple way. Certainly, it was there, and I was very pleased to have Randy Forsberg talk about her wonderfully analytic and devoted concern for this question for many years now, and only feel sorry that Jerry Wiesner was not present to and reinforce that from a quite different perspective. Now, finally, then, the other boundary, which indeed I reached, I guess, sort of about the same time, was the boundary between physics and astronomy. No tight boundary at all, but a very leaky one, and wonderfully crossed, as somebody said, by the physicists, post-war physicists, as it was begun by the pre-war ones, and of course, as it goes back to the time of Newton and of Galileo. Galileo studied the inertial forces, and Galileo developed the telescope and discovered the satellites of the planets, apart from the natural satellite. And that's a nice model. And of course, astronomy, with its extraordinary parametric range and its sense of history inescapable to it, has come more and more to be an important subject for the physicists. The physicists who used to be outside of history and not talk about origins, not talk about the origins of matter or the origins of the universe or even the origins of the laws, are now somewhat concerned with these problems, and as we heard, think they have an answer, which I think is undoubtedly a little premature, but we have something going in that direction. I would not bet we're not going to learn a great deal. I entered this through Professor Rossi, pretty much. I was always interested in astronomy for a very long time, but it was through the cosmic rays, and as one of the, I guess it was a quotation from a paper that showed yesterday, the fact that the cosmic rays have been a wonderful particle physics laboratory was done for at a certain time in the early 50s, not because it was not still an excellent particle physics laboratory, but because it just lost productivity. If you waited for 6 months at Echo Lake for 100 tracks, you could hardly compete with some character in Berkeley or Brookhaven who was getting microamperes in his beam, beautifully sorted and prepared. When he could press a key, on they would come. It was very hard to stay in that game. A few adroit people still do it by combing the very high energy tail where there are fewer and fewer events, which they study with more and more care, but clearly that's a game not many people can engage in. And so it was here at MIT that it slowly arose, around Professor Goldwell as Cornell, there slowly arose the feeling that after all, cosmic rays were not just particles, they were astronomically born particles. And we learned something about astronomy by following them back to where they came from. And as we followed them back, we got somewhat lost from cosmic rays and found X-rays and many other things. Meanwhile, the radio people, coming from a still more engineering point of view. Yesterday I had the label on, which was Jansky's data from 1932. The sign that the interference that he picked up on 20 meters was varied in sidereal and not in solar time. That's the expression in a nutshell, and that was the beginning of the sense that we indeed should study radio astronomy as well as optical, and of course by now the whole gamut, and we have neutrino astronomy of some sort, at least solar astronomy, and some hopes for the rest. That's what I want to say. And I think that I have lived long enough to see the realization of something I heard, which impressed me as being very sensible and philosophical and right, coming from Niels Bohr in 1937 at Berkeley, when in answer to a question Bohr said in one of his public lectures then, which I heard and took notes on as a very eager graduate student, that the trouble with cosmology, which was then a real subject but was geometrical in nature, consisted in studying solutions of the Friedmann equation, and not much else, was that it was essential to understand the nature of matter in order to have a way to go deeper into cosmology. And unfortunately, there was no context in which the nature and structure of matter was found together with cosmologically interesting times and places. And until that context should arise, said he, we will probably not understand the one or the other. And of course, that context now has arisen if we are right in the early universe, and maybe we'll find more as time goes on. That's a prescient thing, and another good example. Well, I'm coming close to the end of all that I want to say, but I have a little more. I received many warm letters. People couldn't be here. I think too many to read. They're all our friends, but it isn't necessary. But I received one which was so apt that I can't suppress it. It came from that irrepressible Giuseppe Cocconi, a very original man, a very knowing and acute one, who is relatively quiet in his demeanor, and so you don't hear a lot about him, but he's very sharp. He said that he is unfortunately unable to come because he finds himself in a very unusual location exactly on this day, Saturday, the 27th September. I would give you a few guesses to where Cocconi might be, but this one is perhaps the most interesting I suppose the South Pole would be a possibility to compete with it, but no, he is in that famous and remote city, the capital of Tibet, the city of Lhasa. Don't ask me how or why he got there, but that's why he's not here today. He said, perhaps some kind of communication will be established by this note, and I hope he will learn by slow means with long propagation time that indeed it was accomplished in that sense, as far as we can do it, where here signal delay retardation is relevant and can't be done as though we were in one time scale. I would like to make real thanks to the apt and to the able and energetic and patient and thoughtful committee and all their helpers who've arranged this fine occasion for us all. And I imagine people would like to join with me in applauding. And I cannot allow the general comment in the committee, who are my good friends, go by without saying just a few words to celebrate and recognize the artist, experimental scientist, craftsman, designer, engineer, caring, devoted, loving, and hopeful person, Phyllis, with whom I've lived for these 25 years. Now, let me close by fulfilling the title of the talk, which said Remarks at an Equinox. Actually, it's printed Remarks of an Equinox, but that's really hard to accept. I'm not an equinox. No one can call me that without smiling. But I am at an equinox in two ways. This is the equinoctial week, after all. And, of course, the autumn comes, and I only want to point out to the physicists who have a good sense of continuity and a good sense of the relativity of geometrical form that we say this is the autumnal equinox. But by what right do we say that? It is, of course, as everyone knows in Australia, the vernal equinox. And I think that's the symbol that I would like to leave, that time passes, but as long as we have representation of the young, of students, of concern, as long as we can keep the peace, I think we need not worry about the future. That is our principal problem. And therefore, let me close in a slightly less philosophical note. I can't avoid the feeling that we have a responsibility to act as we have a responsibility to know. I don't want to do anything formal, but I want to say I do have a very nice letter here, which has been drafted by a friend, an activist friend, for Speaker O'Neill. Here in the 8th Congressional District, Massachusetts, we have a special opportunity and a special responsibility. There are 500,000 people in this district who all know about Speaker T.P. O'Neill, the senior member of the House of Representatives, and the Speaker of the House is retiring, no longer in contention. He's a man whose own growth in political perception I think I've watched in 20 years I've voted for him. And as you may not know, perhaps, the House of Representatives passed very narrowly yesterday their final cut at a bill which authorizes hundreds of billions of dollars of government expenditures, including good fraction of military expenditures, not the whole bill yet, putting into it, at the strong recommendation of the House Armed Services Committee, 3 important arms control statements, which represent the opinion of the House, and I think of the population, if not of the executive branch. Mandating a nuclear warhead test ban under certain circumstances, so they define no money spent to violate that, no money spent to bring down any satellite target in space, that is to maintain the ASAT moratorium, and retaining the SALT II limits, no money to be spent to violate those limits with nuclear weapons. These are in the bill, they're passed. It'll now have to be a big struggle in the next month to see what happens to them. But of a warm note of support and appreciation might be worthwhile. And George Samaripa, who wrote this letter, wrote quite eloquently, the Constitution gave to the House as well as to the Senate the power of the purse precisely to counter the power of an adamant executive. So I have this letter, and I'd be very happy if anybody wants to join me in signing it, just as a colleague and friend. No institutional connection is there. I'll have it all day, and we'll circulate it to whoever wants to do it. So I close with thanks then, and what I say is let the kites fly.
Don't go away, please. There is still to be a presentation by Mr. Brian Mosier, who's the president of the MIT undergraduate organization.
Professor Morrison, the respect and admiration of the students here is clear. You represent very much the MIT spirit. I recall my first contact with MIT was before I came to MIT. And I was a sophomore in high school. And I remotely knew what MIT was about. But my parents called and they said, Brian, there's somebody on TV giving a lecture. And some crazy physics professor from MIT. And they called me in, and I sat with incredible enthusiasm and became excited about MIT in college for the first time. And so you really have an impact on students here in that spirit. I recall last night, after our meal, the challenges that my generation of scientists has. And I think that you stand as an incredible and perfect model for a balance of intellectual playfulness and at the same time a human critical humanity skepticism. We all know what I'm saying. And we thank you for that, and you will stand as a model for us as we challenge the pressures on us to become more narrow and to forget how human we all are. And on behalf of the undergraduates and the students at MIT, I'd like to thank you and wish you a happy Equinox and a happy birthday. And first, we have for you a framed poster.
Splendid! Such a good poster. Thank you very much. Wonderful. I've been stealing it, and all you do. Oh, that's lovely.
And also,
everyone has seen it.
Also, since we were all about to go and have a picnic together, we have for you, Alan, a kite for you to fly. In case your transmitter breaks down, you can tie a few messages to the string.
Okay, good. Thank you very much. Okay, good.